So in 316, we're going to be talking about investigating ratios. So to get started, we're going to start by defining. A ratio is used to express certain relationships between two or more quantities. You are working with ratios when you express portions as percents and fractions. You also use ratios when you compare the portion of raisins or peanuts to the whole mix in the trail mix problem. So you've already been working with ratios, whether you realized it or not. So in our first problem, it says Quinn just had a large pond dug on his farm and wants to stock the pond with fish. He was researching the best way to go about this when he saw the following posting on Pond Person blog. The biggest factor to keep in mind is the predator-prey ratio. Stock the pond with 1 predator fish for every 3 prey fish. Predator fish are largemouth bass or walleye, while prey fish are perch, bluegill, or sunfish. So this is something important to think about because when you are stocking a pond, you don't want to put too many predator fish, but you also don't want to put too many prey. So you have to find a good balance where the predator fish have enough to eat and aren't attacking each other, but have enough prey where they don't all just get eaten right away. So Quinn chose walleye for the predator species and bluegills for the prey. He knows he will need a little over 1,000. So real quick, I want to come up here and I want to highlight we need 1 predator fish for every 3 prey. Okay, that's going to be super important. So every time he throws in a predator fish, he has to throw in 3 prey. So I think to myself, well, how many is he throwing in at a time? He's throwing in 4, right? Because 1 predator, 3 prey. So every time he does that, he's throwing in a total of 4 fish. Okay, but now he wants to fill the fish with a little over 1,000. So we need to think about, okay, what amount of predator and prey will add up to be a little over 1,000 that follows that 1 to 3 ratio. So take a second, pause the video, and see if you can come up with that. Okay, so if he throws in 1 predator for 3 prey, that is a total of 4 fish, right? So the first thing I did was figure out, well, how many sets of 4 do I have in 1,000? So I did 1,000 divided by 4, and I got 250. So what that tells me is there are 250 sets of 4 in 1,000. So he throws in 1 predator, 3 prey, that's 1 set. 1 predator, 3 prey, that's 2 sets. 1 predator, 3 prey, that's 3 sets, and so on. He does that 250 times. So if he does that 250 times, he'll have thrown in 250 predators, and he will have thrown in 750 prey. But problem is, that's 1,000 fish. He wants a little over 1,000 fish. So we'll just add in 1 more predator fish. But remember, if we add in 1 more predator, we have to add in 3 more prey. And that works because that gives us 1,004 fish. All right, next down here it says Rowena and Polly are investigating their trail mix problem again. Rowena took a handful of her mixture and counted her raisins and peanuts. She found she had 8 peanuts and 32 raisins in her sample. Rowena drew the following diagram to represent her sample. So let's do some labeling real quick. This top line, that's representing her peanuts, and she said there are 8 of them. This bottom is representing her raisins, and she said there are 32. Well, total, she has 40 pieces of her sample. So now we're going to use that information to help us with the next problem. It says, for the sample shown above, identify what each of the following ratios are comparing. For example, for a ratio of 40 to 32, you would write total to raisins because the ratio is comparing the total number 40 to the number of raisins, 32. So in this first one, it gives us the ratio. And please remember, order is extremely important in ratios. You cannot write things in whatever order you want, okay? It has to specify somewhere. So for the first one, it says a ratio of 8 to 40. So I have to look at what are they comparing? Okay, well I know 8 is the number of peanuts, so they are comparing the number of peanuts to, and 40 is the total. So 40, or the total. So they are comparing peanuts to total. Now I can't write that as total to peanuts because order is important. The 8 was first. So go ahead, pause the video and try the next 3. Okay, a ratio of 8 to 32. They are comparing peanuts to raisins. A ratio of 32 to 8. They are comparing raisins to peanuts. And a ratio of 32 to 40, they are comparing raisins to the total. For B down here, okay, use what you have learned about portions to describe what portion of Rowena's sample is peanuts and what sample is raisins. So let's start off with peanuts. So her fraction is she had 8 peanuts out of 40, okay? Because we want to know what is the percent out of the entire sample. So that's why we're putting it out of 40, okay? And we also want to find the percent. So a couple ways you can go about this. Hopefully you realize that we can't make an equivalent fraction with 100 on the bottom the way it is. So you could either simplify 8/40ths and make an equivalent fraction out of 100 to get your percent. Or remember, the fraction bar means division, so you could just do 8 divided by 40. You'll get 0.2. We move the decimal 2 places to the right, and you get 20%. Now let's look at raisins. So her fraction for raisins was 32 out of 40. So if I wanted to find that percent, I would do 32 divided by 40, which gives you 0.8, 2 places to the right, which gives you 80%. And that makes sense because our 2% should add up to 100 because it's 100% of our sample. So you could have realized, oh, okay, peanuts is 20%, so the rest has to be raisins, which is 80. All right, go ahead, look at the next page. So there are 3 ways that you can write a ratio, and they are right here. The first way is you could write it with the word 2. So you would write the ratio of raisins to peanuts is 4:1. You could also write it as a fraction. So the peanuts and raisins have a ratio of 1 peanut to 4 raisins, so you'd write that as 1/4. And with a colon, the ratio of peanuts to raisins is 1 with a colon 4. So those are the 3 ways that you would write ratios. So let's practice that. Sidra has a sample of trail mix containing 22 raisins and 28 peanuts. Use the bolded list above to write the ratio of peanuts to raisins. We're going to highlight that, okay, because order is extremely important. It says to write them in peanuts to raisins. So go ahead and pause the video, see if you can write the ratio in all 3 of those forms real quick. Okay, so let's do peanuts to raisins. So with the word 2, we would write 28 to 22. And remember, the 28 comes first because our peanuts comes first. We just highlighted that order. As a fraction, you would write that as 28/22. And with a colon, you would write that as 28:22. The last question says, what would you have to change to write the ratio of raisins to peanuts? So we have to think about what would we do if we wanted to write, instead of peanuts to raisins, we did raisins to peanuts. And hopefully you can recognize we just switched the order. All right. Ratios like fractions can be written in simplified form. The ratio of 32 to 8 can be written equivalently to 4 to 1. So just like we would simplify fractions, we simplify ratios. So I'm going to look at our one from above, 28 to 22. You got to think to yourself, what could I simplify by? What goes into 28 that also goes into 22? And hopefully you come to the realization that each one can be divided by 2. And remember, we're simplifying, so we're dividing. So this becomes 14 to 11. And then again, you can copy it down in all three forms. This would be 14 over 11 and 14 colon 11. Okay. Now we're going to find the percent of Cedra's trail mix, that is peanuts. So up here, it says she had 28 peanuts and 22 raisins. So first, let's find our fraction. What is the fraction of Cedra's trail mix that is peanuts? Well, she had 28. And I know a lot of you are going to say over 22. No, it is out of 50. Because remember, we're finding it out of the total. So the 28 is representing the peanuts. And the 50 is representing the total. Because 22 plus 28 equals 50. Now we can use that to find the percent, and I notice that I can make an equivalent fraction out of 100. So I multiply the bottom by 2. I do the same thing to the top, and you get 56. So it's 56%. And I'm still using my giant 1. Here it is right there. Okay. It's just not as fancy. So go ahead and pause and try to see if you could do the same thing but for her raisins. All right, let's start out with our fraction. Her fraction for her raisins was 22 out of 50. Again, the 22 is representing the raisins, and the 50 is representing the total. So now we need to make a percent. Again, I can make an equivalent fraction out of 100, because all percents are out of 100. I'd multiply this 50 by 2, and what I do to the bottom, I do to the top. And you get 44, which is equal to 44%. And that makes sense because both of these add up to 100%. There's my giant 1. All right, and that is 316.